let's look at a new unit that we use all the time in chemistry. That's the unit of molarity. This is a unit for solutions. A solution is when you've taken a substance and dissolved it, typically in a liquid. So for instance, if I dissolved salt in water, I'm going to make a solution. And molarity is used to determine exactly how concentrated that solution is. So molarity is simply given by moles of solute, that's what I've dissolved, divided by liters of the entire solution. You can see it looks a lot like density. And for those of you who love the density triangle, we can make a very similar one for molarity. Molarity is equal to moles over liters. So we can use this to interchange between moles, molarity, and liters. If we have to, we can get the third one. Keep in mind that for moles, we can go to grams. So oftentimes molarity problems involve grams, and it seems like it doesn't belong, but it is very easy for us to convert between grams and moles. So with grams, you can still convert it and then put it in your triangle. Another thing we do with molarity all the time is dilute things. We often have a very concentrated solution called a stock solution, and we need to make a more dilute solution. Let's say we had 12 molar HCl, and I wanted to make a 2 molar solution. We would have to figure out exactly how much of this I would need to dilute it and make a less concentrated solution. And the good news is we have a very simple equation for that. M1V1 equals M2V2, where M stands for molarity and V stands for volume. And typically on the left side, we put the molarity and volume of our concentrated solution, whereas on the right side, we put it after we have diluted it. So this would be our less concentrated solution on the right. So let's look at a couple ways we might see molarity problems. For instance, what mass in grams of lithium fluoride is needed to make 500 milliliters of a 0.750 molar solution? So let's just write out the information we have. If we look at our givens, we have 500 milliliters of a solution, has a concentration of 0.050 molar. I'm looking for the grams, and I'm looking for grams of lithium fluoride. So we need this formula. You know, lithium is +1, fluoride is -1. So together they're just going to be LiF. So I'm looking for grams of LiF. So there's a couple different ways that we could approach this problem, and I'll show us both ways that I like to look at. So the first thing I like to do is if I see molarity, big M, I remember that this really stands for moles per liter. And now this just looks like a fraction. So we have milliliters, we have a molarity, a conversion factor, moles over liters, and we want to end in grams. If we treat this just like any other conversion problem, we would look at this and say, okay, well, I have a number by itself, so that's always where I start my problems. So I'm going to start with the milliliters and see where I can go. I don't have anything else with milliliters, but I do see liters right here. So I say, all right, I must need to get rid of the milliliters and turn it into liters, where 1 milliliter is 10 to the -3rd, that's a 3 there, -3rd liters. So now we've gotten rid of the milliliters, now we have liters, now we can use this second piece. So we say, let's get rid of the liters, and that means we're going to 0.750 moles, this is moles of lithium fluoride, on top. So now we've eliminated the liters. Well, we've gotten to moles. We want to end in grams, and although it didn't give us a conversion factor for that in the problem, we've seen this enough that we know what to do. If we have moles and want to get to grams, we simply use the molar mass. So I use the periodic table and calculate it. For every 1 mole, it is 25.94 grams for lithium fluoride. So that means my moles will cancel. I'll end up with grams of lithium fluoride. Do the math. I get 9.73 grams. So key thing to keep in mind is that big M is a combined unit. It means moles per liter. We can use it in a conversion problem just like this. Now, some of you aren't going to like that. You're going to want to use the triangle. So the other approach that you could take with a problem like this is to recognize, well, I have a volume and I have a molarity. I must be able to use the triangle here. Molarity is equal to moles over liters. And if you eventually want to end up in grams, if you first calculate your moles, that's an easy thing to do. So you could first use this equation. Molarity is equal to, moles is equal to molarity times liters, right? If we're solving for this piece, we multiply those on the bottom. You can plug in your molarity. You would take your milliliters and convert those to liters. So you would have moles is equal to 0.750 molar times your liters, which if we converted would be 0.500 liters. That would give me my moles, which would be 0.375 moles. And then you could use the molar mass to convert that into grams. So some people really prefer to use the triangle, and you can do it that way, or you can just do the conversion way as I showed first. In different molarity problems, you're solving for different pieces, but you should always get two things in the triangle or have enough pieces to get there. So sometimes you're solving for liters, sometimes for molarity. Just keep in mind that big M equals moles per liter, and then you can see how your units are going to work out. So let's look at a different type of problem we might see. Also a molarity problem, but we're going to approach it very differently. To what volume should you dilute 25 milliliters of a 10 molar sulfuric acid solution to obtain a 0.150 molar sulfuric acid solution? Key word here is dilute. Anytime we see that dilute, we're probably going to use the dilution equation. So let's put the concentrated stuff on the left. Also, we can think of that as the before. And we'll put the diluted stuff on the right. We can also think of this as the after. So we just need to plug in our numbers. We start with a 10 molar solution, and we have 25 milliliters of it. So that's my M1 and my V1. We want to end with a 0.51 molar solution, and we're looking for that volume, so we don't know the V2. That's it. You're always going to get 3 out of the 4 pieces. You just got to plug them in. So we divide both sides by 0.150 molar. Cancels over here. Here my units cancel at least. And I find that my V2 is 1,667 milliliters, because I had milliliters right here. But with 2 sig figs, that turns into 1,700 milliliters. So I didn't actually have to use the molarity equals moles over liters in this case, because I was simply diluting it. So look for that key word dilute, and that tells you you're going to be using this equation right here.